Okay, here we have another equation with a lot of fractions, and we're going to tackle it the same way we tackled the previous equation, which is we are going to look for a common denominator, LCD, least common denominator, and we have to consider all the fractions in the equation. So we have denominators of 3 and 2 and 6 and 2. So we want to think of all four of these denominators when considering the least common denominator. And this one's a pretty easy one. The least common denominator in this case, which is the smallest number that is divisible by each of these numbers, is going to be the number 6. All right, so 6 can be divided by 3 and 2 and itself and again 2. So 6 will be our least common denominator in this case. What are we going to do with the least common denominator? We will multiply the least common denominator to both sides of the equation. And just like we did in the previous example, we are going to have to distribute the 6 to the left-hand side and to the right-hand side. Now this one has a little bit of a tricky situation in that on the left-hand side, it's very common for students to want to distribute the 6 to the 1/2, multiply it to the 1/2, but also multiply it into the parentheses and distribute it to the 1 minus x. And you cannot do both because the 1/2 and the parentheses, 1 minus x, are all part of the same term. The 6 we're going to multiply by can only be multiplied to each term one time. We can only use it once. We can use it once on the 2/3 x because that's one term, and we can use the 6 once on the 1/2 times 1 minus x. All right, so keep that in mind as we work through this problem. So let's go ahead and distribute the 6 to the left-hand side of the equation, and here's what it's going to look like. We're going to multiply the 6 to the 2/3 x, and we're going to multiply the 6 to the 1/2 times 1 minus x. We'll also distribute the 6 on the right-hand side, so the 6 gets multiplied to the 1/6 x and also to the 1/2. And because the 6 is going up against all these fractions, we will think of the 6 as a fraction as well by writing it as 6 over 1. So let's go ahead and write this out to see what it looks like. We'll have the 6 over 1 getting multiplied to the 2/3 x, and we'll get the 6 over 1 being multiplied to the second term, the 1/2 times 1 minus x. We'll do the same thing to the right-hand side. We'll multiply the 6 over 1 to the 1/6 x and the 6 over 1 to the 1/2. And what we're going to do, just like we did in the last example, is we're going to simplify. And what should happen is that all the fractions should just disappear. So in the first term on the left-hand side, what's going to happen is the 3 in the denominator will cancel out with the 6 of our common denominator, and will leave us with a 2 on top. And again, the denominator basically gets emptied out. The 3 gets canceled out. We do have a 1 left behind, but the 1 just doesn't have to be written. We just drop it. We leave it alone. And so it won't be a fraction anymore. Right? In the second term on the left-hand side, the 2 in the denominator cancels out with the 6 and leaves me with a 3. We'll come back and clean this stuff up here in just a minute. On the right-hand side, very similar things happen. The 6's cancel out in the first term on the right-hand side. And the second term, we have the 2 canceling out with the 6 and leaving us with a 3. The way we simplify this is we multiply whatever's left over from our common denominator to the numerator that was already there in the fraction in the equation. And in every case, it will be over 1, and we can drop that 1, and again, it will no longer be a fraction. So let's take a look at the first term on the left-hand side. What's going to happen is that the 2 that was left over from our common denominator gets multiplied to the 2 that was already there in the equation, and we end up getting 2 times 2, which is 4, over 1, which, again, the 1 gets dropped, and we just write that as 4. Right? The x gets copied down, and so that term simplifies down to just 4x. For the second term on the left-hand side, we will have the 3 that's already there, or sorry, not already there, the 3 that was left over from our common denominator getting multiplied to the 1 that was already there, and we'll end up with 3. Again, the parentheses will just get copied down, just like the x got copied down in the first case with the first term. So we get 3 times parentheses 1 minus x. So again, notice that the 6, the common denominator we multiplied by, only got used one time. It was used to cancel out the 2 in that denominator, and that was it. We couldn't use the 6 again to also distribute into the parentheses. Right? On the right-hand side, again, the 6 is canceled out. We have a 1 left over from our common denominator, multiplied to the 1 that was already there. So 1 times 1 obviously is just going to be a 1. The x gets copied down, so we get 1x. And in the last case, we have a 3 left over from our common denominator times the 1, which gives me 3. Right? 3 over 1 is equal to 3. And again, what happened is that all the fractions disappeared. No fractions remain, and that's going to make it a lot easier to solve this equation. So that's really the hard part of this equation. Now we can move on to the easy part, which is to solve what you see here. 4x plus 3 times 1 minus x equals 1x plus 3. So let's go ahead and do that on a new screen. The first step to solving this equation will be to distribute the 3 into the parentheses. So let's go ahead and do that. We'll get 4x plus 3 minus 3x equals x plus 3. Notice on the right-hand side, the 1x, I just wrote that as x. The 1, again, doesn't have to be written there. 1 times x is just x. Before we start moving things from one side of the equation to the other, I always like to simplify each side of the equation first. So on the left-hand side, we can simplify by combining the 4x and the negative 3x. We do not need to add the negative 3x over to the 4x because they're already both on the same side of the equation. We just combine them together. The 3 in the middle can be ignored because we can always move these terms around. They are commutative. They can be moved, and so we could always put the x's together and put the 3 last. We don't usually bother writing that out, but that's what allows us to go ahead and combine these together even though there's a 3 in the middle. So we get 4x minus 3x, which is just going to be x. Right? The plus 3 gets copied down, and on the right-hand side, we just copy that down as well. We also have an x plus 3 on the right-hand side, which is very odd. Right? We get the same thing on the left-hand side that we have on the right-hand side. And in fact, this is a special case that we talked about in the previous video. What we have here is an identity. So we can find that out by continuing to solve this equation. We would want to get x on one side of the equation, so I will cancel it out from the right-hand side by subtracting x from the right-hand side, which means I have to do the same thing to the left-hand side, and it gets canceled out from the left-hand side as well. So anytime your variable just disappears from your equation like this, you know it's a special case. It either has to be an identity or it has to be inconsistent. And to decide which one it is, we see what result we get here. So after the x gets canceled out, the result we get here is that 3 is equal to 3. Right? We have a 3 left over on the left-hand side, a 3 left over on the right-hand side. So the result is 3 equals 3, which is true. Right? This is a true statement. And if it's true, that tells me that this equation was an identity all along. Even though the original equation didn't look anything like an identity because the left-hand side didn't look anything like the right-hand side, it turns out, in fact, they are identical. The left-hand side is identical to the right-hand side. And whenever that's the case, the solution set to your equation is all real numbers, meaning there's an infinite number of solutions. Any value that you plug in for x will make the equation true. Any number you could think of makes this equation true, which means any number is a solution. So the solution set is all real numbers, and this type of equation is called an identity.